Right. And they actually said transitivity here. That is a term for it, but for my test, I want you to say syllogism. Those are the options on the test, by the way. It's a form of transitivity. That's what it represents. All right, 40. They just wanted you to say what rule says that you can do this. Same actual concept. If RS equals WX and WX equals BC, then RS equals BC. That is transitivity as well. Transitive property of equality. Number 3 wants you to determine if the conjecture is true or false. If it is false, provide a counter example. All right, this is similar to our quiz. You will have something like this on your test. Is it true or false? If it's false, provide a counter example. Then I want you to write the notation for conjunction, disjunction, and your rules. How do you read it? When is it true? And then I picked out one of these for you to do, number 6. It gave you just the phrases here, and then it wants you to do this particular one. So all of this first page is way back what we did at the beginning. You have to know your notation for this, and you have to be able to tell if it's true or false. And then for the one at the top, you have to provide a counter example, which you'll have to do for some of the others as well. So go ahead and go and do those right there. 3, fill out the compound statements, and then do number 6. The square of a number is always larger than the number. Is that true or false? This is false. Fractions work. 1 works. 1 squared is not larger than the number, right? 1/2 is not, the square of 1/2 is not larger than 1/2, 1/4, etc. All right? Conjunction. Your notation for conjunction is the V that looks like it's upside down. Conjunction. This is and or. And. So you read it as P and Q. It is true when both statements are true. When both statements are true. So your and is when they are both true. If they are not both true, the entire statement is false. All right, disjunction then is the notation like this. Looks like a V. This is or. It is true when at least one statement is true. At least one statement is true. All right, so you can have 1 true or 1 false. If it is an or, then the whole entire statement is true. So let's look at this one. They want us to use all vegetables are green, vertical angles are congruent, and all integers are natural numbers. Determine the truth value. So your statement should have looked like this. Vertical angles are congruent, and all integers are natural numbers. Sorry, we just wrote extra words there. And all integers are natural numbers. All right, so is that true or false? True or false? Yeah, why is that false? Right, your natural numbers are only your 1, 2, 3, 4, 5, etc. Integers include the opposites. So you would say false there. All right, questions on that one? All right, so on this page, I want you to do just that small truth table. I've actually set up the P and the Q columns for you. Already set up the P and the Q columns for you. So I want you to finish that one out with the not P, the not Q, and then what they ask for. I also want you to give me the notation for conditional, inverse, converse, and contrapositive, but I only want you to do conditional for right now. We'll go back when we are done going through it together and let you work on that. So the first 2 columns are simple. What does that little symbol in front of the P and the Q mean? Not. So it's the opposite, right? So whatever was in the P column, you're going to do the opposite. So instead of true, true, false, false, it's false, false, true, true. All right? So that one's easy. Look at the next one, also easy. Whatever was in the Q column, you're going to do the negation of. So instead of true, false, you're going to say false, true, false, true. All right? So then we're going to do the next one. What is the symbol in between the mean? Or. All right, so if I have not P or not Q, I'm going to look at these last 2 columns here to determine my truth. It is or, meaning at least one has to be true. So in the first one, false, false. That means that whole thing is false. False, true. That whole thing is true because one of them is. Same thing for the next one. And then, of course, if they're both true, it is also true. For our conditional statements, all right? Conditional, that is just P and then Q. If P, then Q. Inverse keeps them in the same order, but it negates them. Not P, then not Q. Converse then switches them. So converse just switches the order. If Q, then P. And then contrapositive switches and negates. Not Q, then not P. Not Q, then not P. So then the conditional statement here is just the if P, then Q. If two angles form a linear pair, then they are adjacent angles. Is that true or false? That's true. The definition of linear pair is, part of that definition is that they're adjacent. Part of that definition is that they are adjacent. So that is true. All right. Biconditional goes both directions. So it is read if and only if. And in order for a biconditional to be true, you have to be able to say if then, and that is true, and then you have to do the opposite. You have to do the converse. If then the other direction must also be true. If it is true both directions, meaning your conditional and your converse are both true, then your biconditional is true. And so what they've done is they want you to do a conditional, a converse, a biconditional, and then they want you to determine the truth value. And so I'm going to leave that because that's the only example that y'all have here. But what a biconditional does is it combines the conditional and converse with an if and only if in between it. Instead of an if then, you would just say one statement, if and only if, the other statement, and it's true both directions. So we had two types of deductive reasoning, the law of detachment, the law of syllogism. We had notation for these as well. All right, so I want you to do the notation for these, and I want you to do just number 16. Read the statements that they've given you. Tell me what type of reasoning they are trying to use, and then tell me if it is valid or invalid reasoning. If it's valid, then what conclusion can you come up with? All right? So if it is valid, then I need you to tell me what your conclusion would be based on the statements that they gave you. Law of detachment. Law of detachment says that if you're given an if-then statement, that's your initial. You're assuming that's true. And then you're given the if part of it. It doesn't have to be exact. It just has to meet the criteria of the hypothesis. So you're then given a statement that meets the criteria of the hypothesis. Therefore, you can conclude the conclusion. All right? Your conclusion would be the conclusion of your if-then statement. The little 3 dots just means therefore. So if P, then Q. You've been given P, so therefore Q. All right? That's when they break it apart, detachment. Syllogism is similar to transitivity. If P, then Q. If Q, then R. Therefore, if P, then R. All right? So the example they've given us is if it's Thursday, then Emma has a drama club. If Emma has a drama club, then she must take the late bus. All right? So what rule are they wanting us to use here? Syllogism. Syllogism. If then. Okay? So then what can we conclude? Yeah, if it is Thursday, then Emma must take the late bus. We can go straight from the beginning to the final end. That is syllogism. It is similar to transitivity, and it is often called transitivity. When you are doing these algebraic proofs, make sure you pay attention to the proof itself. Work the algebra problem out so that you can actually see what you did. And so in this case, you're going to use distribution. You're going to use addition or subtraction property of equality. You're going to use multiplication or division property of equality. On the proof that I have for you, which they did not leave enough lines on this particular one, I just didn't spread it out for you. I do want you to put a separate line for simplify. Okay, so for this proof, you would actually have 1, 2, 3, 4, about 9 lines there. Okay, you would have 9 lines. So if you have to add lines to it, that's fine. I will give you the exact number that you need on your test. Okay, so you need to do a process, and then you need to simplify the process. You need to do a process, simplify. All right, for these algebraic proofs. So for this one, again, key things, segment addition postulate is used all the time. Definition of midpoint, that's what we just talked about in the last section. Definition of congruence, obviously we use congruence all the time. And then the properties, reflexive, symmetric, and transitive. Remember, if you're adding or subtracting, that is a property of equality. So you have to have it in an equality to add or subtract things. So that's where you're going to possibly go from congruence to equality and then back to congruence in a proof. So go ahead and try this particular proof. And then we'll go through these steps together. This one's simple. How do we know that AB is congruent to CD and CE is congruent to AE? That is given. Always get the given, right? What about the next one? AB equals CD and CE equals AE. Definition of congruence. We should probably always look for that one as well. Now let's look at what they've done in this next one. They have said that AE plus EB equals AB and CE plus ED equals CD. So when you're not sure what they're talking about over here, look at your picture. We have that AE plus EB equals AB and CE plus ED equals CD. What tells us that? That's segment addition postulate. Segment addition postulate tells us that. All right? Now, for this next one, we have CE plus EB equals CD. All right, so what have they done here? What have they done in this particular equation? They've substituted. So they took out this E, they took out part of this and they replaced it with another, all right? Substitution, all right? Now they have CE plus ED equals CE plus EB. Why can they do that? I would actually take 2 here because it's equality. Yeah, transitive or substitution. Transitive or substitution. All right? Because it's equality, you could do transitive or substitution there. Transitive or substitution. All right? For this next one, instead of saying CE plus ED and CE plus EB, they just have the ED and the EB. What did they do to both sides here? Subtraction property. All right, subtraction property. And then the last one's fairly simple. They went from equality to congruence. Definition of congruence. All right. They have at the top all the things that might possibly apply to these particular proofs. And so you need to make sure that you know what these mean. There will be sections on your test where you have examples of these and you have to match them or do multiple choice for them. So make sure you can recognize these properties, not just in a proof. All right, so go ahead and try this quick proof and then we'll go over it. All right, let's go over this. Angle JKM and MKL form a linear pair. How do we know that? Yeah, that's given. If they form a linear pair, then they're supplementary. What tells us that? Supplement theorem. All right, supplement theorem. JKM and LKN are supplementary. How do we know that? It's also given. So then how do we know they're congruent? The congruent supplements theorem. Congruent supplement. So if 2 angles are supplementary to the same angle, then they are congruent. That is what your congruent supplements theorem says. 2 angles are supplementary to the same angle. You can see that MKL and LKN were both supplementary to JKM. If they're supplementary to the same angle, then they must be congruent. They must be congruent. That is your congruent supplements theorem.